All right, good day, everyone. And we'll get started, right? Also, just something really quick. So, couple quick announcement. So, all the homework is due by next Friday. So, you should submit the homework assignment as either Word file, Excel file, or PDF file, right? And I will create Dropbox I'll create Dropbox for you to submit it by next Wednesday. So. And also review next Wednesday, just another reminder. Okay, any questions before we get started? All right, so we're gonna finish the lecture on section 2.3 today. And then from there, we move on to your Excel project number 3. So you just finish the Excel project number 3 today. Okay. All right, so first of all, let's look at, let's open the PowerPoint and finish up the last session before the first exam. And then we are working on the application of the exponential functions, just mainly in the human population growth. So we're going to take a look at that more thoroughly today. Okay. So again, let me just quickly remind you that the model we are using here is NT equal to N0 over N0 times e to the KT. So here NT is a population after T years, right? And N0 is the initial population. Yeah.
Can you share the screen, please?
Yeah, sorry, yeah, I forget. Okay. All right, here you go. Should be that. Just slideshow. Okay. Share screen. Okay, so you can see the screen, right?
Yeah.
Okay, great. So N0 is what we call the initial population. Usually it's a population at time t equal to 0. Okay. And the K is the annual growth rate, and T is the time in years. And that's the model we are utilizing to calculate any missing elements in a particular context, or maybe you could just use that to predict the population in the near future. And we went over a couple of these questions. I think this one as well. Yeah. I guess yes. I think we went over example 4, right? Is that the case? Do you remember that? Okay, and then quickly double check, right?
Yeah, we did this one.
This one. Okay, great. All right, so now let's take a look at example 5, right? So let's say India's annual growth rate is 4.8%. At this growth rate, how long will it take for the population to double? Okay, so this is just hypothetical case. So here we do not have too much information besides annual growth rate, but that's for sure, we know that. So K is given 4.8%. So this is 0.048. Okay, so we get it, one of these real numbers. And then how long would it take for the population to double, meaning how long here indicating we're looking for time t. And here there's no actual number for the initial population and the population after time t, but there's a relationship, because in order for population double, meaning NT, after t years, NT become twice as much as N0. Okay. So this is one of the given condition here. So, and since it's not the, the amount of population is not given here. If you want to make assumption, let's say India's population is, as let's say 1 billion or something like that, that's fine, right? And then that means you in order to reach 2 billion, how long does that take? But we will stick with this relationship here, NT equal to twice of N0. Now we'll still write down the formula, NT equal to N0 times e to the KT. And we're going to plug in whatever we know, right? So NT will become twice of N0 here. So 2N0, twice of N0 equal to N0 times E. Then K here is 0.048. So 0.048 times T. Okay. And right here, we need to solve a T. So first of all, we could divide N0 from both sides of the equation. Okay, we get that. Then we cancel N0 and get e to the 0.048 t is equal to 2. So now, as you can see, although we don't have the actual number for the initial population and the population after t years, but that is not relevant, right? After we cancel N0, you know, just a constant of 2, meaning that, so doubling is happening here, right? So it becomes constant factor becomes 2. And in this case, we still try to solve for the t. So taking ln from both sides of the equation, equal ln of 2. And we know that this is a general principle, ln of e to the x becomes x. Right? This is one of the property in the logarithm field. Okay, so we offset that, so end up with 0.048 t equal to ln of 2. Then eventually we're just dividing both sides of the equation by 0.048. Then we come up with the time t we try to solve for. So the constant can cancel t by itself. And we put this into the calculator or the Excel. We get a result. So ln of 2 by 0.048, that becomes 14.4. So that about, in that case, is about 14.4 years. In about 14.4 years, the population will double, right? Based on this constant growth rate. Okay. Any question on this problem? Okay. And now let's look at this. Okay, questions. I think it's the same question here. Okay. Question 7. How long would it take for population with a growth rate constant of 2.7% to increase by 80%? Okay. So now again, this question, the constant growth rate is given 2.7%. So K is equal to 2.7%. Okay, so that's 0.027. That's first piece of information we extract out of the question. And again, they asking for how long, right? So that means we're looking for time t. And increase by 80%, meaning assuming, again, there's only relationship here. NT is N0 plus additional 80%. And that's what this means. Meaning you're adding additional 80% to this, so 80% of N0. Okay. And we will be able to clarify the relationship between those two, which is N0 plus 0.8 of N0. Okay, that becomes, this is 1, right? 1 times N0, and this is 1 plus 8.8 is 1.8 times N0. And now it's just like similar to the previous one, right? It's double, but here it's 1 times as much. Okay. So again, we come up with a relationship between the population of the time t and then also the initial population. So the population of the time t is 1.8 times as much as the initial population. So now one more time, we just apply the formula. NT equal N0 times E to the KT. Now throw in NT with a 1.8 N0. And this is N0 times E. K is 0.027 T. Okay. And from there, we divide N0 from both sides of the equation, just like previous one. And then again, N0 will be cancelled. Then we end up with E raised to 0.027 T equal to 1.8. On the left-hand side, N0 get cancelled. And I've just reversed the order of the equation. So the variable goes to the left, and then the constant goes to the right. And right here, again, we taking ln from both sides of the equation to simplify the equation to 0.027 T. And this is ln of 1.8 on the right. Okay. And then ln and E offset each other. So we end up with 0.027 T equal to ln of 1.8. Okay. And now from there, we're just dividing both sides of the equation by 0.027. Okay, and cancel that, then time t is by itself. Let's see what time t is. So again, put into the calculator, and let's get a result. Divided by 0.027. That turned out to be 21.8 years. So this is about 21.8 years. Okay. To increase the population by 80%, right? So take about 22 years. Okay, so that's I think that's everything on the PowerPoint slide. So do you have any question on this? Okay, so now we can take a look at some of the examples from your textbook. Okay, so let's go to textbook. So let's open textbook, move on to the exercise in the back of the textbook. And you are only responsible for the R problems, right? Not the even ones. Usually we'll go over some of the even questions from the exercise in class, and you're only responsible for the R ones. Right? In terms of submitting your homework, you only work on R questions. Okay, so let me just go a little bit before I. Exercise 2.2, and then we're going to move on to exercise 2.3. Let's take a look at some of the exercise in the back. Okay, so now I give you a couple minutes, look at the question 2 and question 4, right? I give you maybe a couple minutes, quickly solve it, and then we can go to the solution together. Okay, so let's go over the solution for those two questions. So move on to this note. Okay. There we go. All right, so question number 2, you are looking for how long will it take, right? So it's looking for time t here. Will it take for the population to grow to 5 million? So here the initial population is N0 is 3.2 million. And the population after certain years is NT is 5 million. And the growth rate is 1.8% per year. So that's annual growth rate K, 1.8%. So this is 0.018. Okay. And we are looking for time t here. So we set up the equation, right? So plug into the model NT equal to N0 is e to the KT. So throwing all the numbers here, so it's 5 million or 3.2 million times e raised to 0.018 t. And first step, we're just gonna isolate the variable part, right? This part. So dividing 3.2 million from both sides of the equation. So we cancel that, the coefficient in front of it, and reverse order, and then cancel the unit million. So e raised to 0.018 t equal to 5 over 3.2. So if you don't want to turn your decimal, leave as is, right? It's more accurate answer. And from there, we're taking the ln from both sides of the equation. So taking the ln here, taking the ln to the right. Okay. Then we cancel, simplify, and then we get 0.018 t becomes the only thing remains, right? ln and exponents with base e, they cancel each other. So ln of 5 over 3.2 on the right. Now the very last step is dividing both sides of the equation by 0.018. Cancel that. So t is by itself now. So ln of 5 over 3.2 dividing by 0.018. And you can throw into the calculator or Excel and get a result. And let's see what that is. ln 5 over 3.2 dividing by 0.018. And that's 24.8 years. Okay, approximately. If you run it to one decimal place. And if let's say people want a slightly more accurate answer, let's say we're gonna get 24 years, right? And then we're gonna decompose 0.8 years as month and days. So 24.8 years, we know will be 24 years. And 0.8 years should be 0.8, 1 year equal 12 months. And that's 9.6 months, right? That means we're taking the whole number 9, so it's 9 months. And then if you look at 0.6 month, so we still have 0.6 months remains. So 0.6 months should be 0.6 times 30 days per week, 30 days per month. So you get 18 days. So if you want a slightly more accurate description of what is 24.8 years, will be 24 years, 9 months, and 18 days. Just try to decompose it into year, months, and days. Right? You can do a quick conversion. Right? I just want to show you how to do that really quickly, just in case you want to get a little bit more accurate result. Okay, this is question number 2, and let's look at question 4. All right, so for question 4, this Venezuela's population is expected to be 35.3 million in 2027. So 2027 has a future. The growth rate is 1.9% per year. So we know growth rate is 1.9%. So this is 0.019. And what was Venezuela's population in 2006? And you're assuming in 2006, this is the initial year. So this is where the initial population occurs. So N0 occurs here. And then in 2027 must be NT, right? So NT must be 35.3 million. Between, and we also know time T, between 2006 and 2027, there are 21 years, using 2027 minus 2006. And the difference will be the time T in years. So this is 21 years, okay, in between. Now we just summarize all the information, although some of them are not very straightforward. You still got to do calculation, you have to get that. But yeah, summarize whatever we have from the question. And definitely we're looking for N0. That's not given here. Looking for the initial population in 2006. Okay. So now similarly, you just write down the formula first. NT equal N0 times e to the KT. Now we plug in all numbers given here. NT is 35.3 millions. Okay, and then N0, that's what we're looking for. K is 0.019 times T is 21. Okay, so in order to solve for N0, you just need to divide both sides of the equation by this exponent. So we're dividing both sides of the equation by e to the, and if you want to multiply those two numbers, 0.019 times 21, you could do that. Just keep single number. So it's 0.399. So this is 0.019 times 21, that's 0.399. So it's dividing both sides of the equation by e raised to 0.399. E raised to 0.399. And now we cancel that, and the N0 is by itself. And I just have to input into the calculator one more time. So reverse order, N0 goes first. So you get 35.3 million dividing by E raised to 0.399. And one more time, you put into the calculator. Let's get a result. And then the unit million remains, right? So we do 35.3 dividing by E raised to 0.399. That's 23.7 approximately. So this is approximately 23.7 million. That means the initial population for Venezuela will be 23.7 million. Okay, so this is the initial population in 2006. 23.7 million. Okay, do you have any question on those two, on this particular problem? Okay. So let's go back to the textbook. So it's exercise 2.3. So you need to work on 1 and 3 yourself. Okay, it's very similar, right? Most of these questions very similar. And if you know how to do some of them, you know how to do all of them. And let's take a look at questions 6 and 8. Right? Maybe just call these 6 and 8. I give you some time to work on it before we go over the answer.
Which one are we looking at, Professor? I'm sorry.
Question 6 and 8, all even ones, right? We just went over 6, 8. If you want, you can also look at question 10 if you finished 6 and 8 already. Okay. Okay, so let's go over the solution for question 6 and 8. All right. Here we go. So question 6 first. The population of the world is estimated to be 6.396 billion and grows at a rate of 1.3% per year. How long before the population grows by 75%? So one way to do this is we know the N0, right? So which is 6.396, okay, billion. Okay, so if you want to keep the unit, you can keep it. Okay. We'll just stick with the same unit, billion. And NT should be grows by 75%, meaning you gain additional 75%. So be 6.396 plus additional 75% of that on top of that. Okay, so it's adding additional 75% of this, and you get the total population after this amount of years. So let's see what that is. 6.396 adding 0.75 times 6.396, and that turned out to be 11.193. Meaning we're looking at the population of 11.193 billion after certain years, and we try to figure out how many years is that. Okay, so we're still looking for time t, and here the k is given. K is 1.3%, so this is 0.013. Okay, then one more time, we just need a formula nt equal to n0 times e to the kt. Okay. Now we're plugging all the numbers. Nt is 11.193 billion, right? So if you want to omit a unit, that's fine, right? You can omit it. So then n0 is 6.396, and times e, k is 0.013 times t. All right, so now from there, we just need to solve for time t. So first of all, we're dividing both sides of the equation by 6.396. Okay, 6.396. And then if you, without a calculation, even without dividing those two numbers, what should be the proper result when we're dividing 11.193 by 6.396? Any idea or any suggestion? This should be 1.75, right? If you use a calculator or Excel, but without calculating that, it should be 1.75 times as much, because population grows by 75%. The base is 1. You add in 75%, so it's 175%, which is 1.75 times as much as the initial population. So now reverse order equal to 1.75. Now from there, we take in LN from both sides of the equation. Equal LN of 1.75. Now from there, simplify the equation, so these two cancel each other. So we get 0.013 t equal ln of 1.75. Now dividing both sides of the equation by 0.013, now we get a solution. Okay, so let me quickly review the Excel skills review. So I'm going to show this in Excel now. So we get a ln of 1. So put into the Excel, putting ln, typing ln 1.75 and dividing by 0.013. Okay. And that should give us a proper answer. And if you run it to one decimal, it's a 43.0, right? You run one decimal place. Okay, 43.0. So it takes about 43 years. 43.0 years. Okay, for the world population to gain additional 75%. Okay, so that's solution for question 6 and question 8. Okay, What is growth rate of population that doubles in 35 years? Okay, so again, it's a doubling problem. So this, you can call this type of problem. It could be tripling, right? Quadrupling, right? Depends on the setting here, but this is definitely doubling time we're looking at. And we are given the time t. Time t is 35 years. Okay. And then we have a relationship between the population after 35 years, which is ending population NT, and initial population N0. So NT is twice as much as N0. Okay. And that's all we have. It's very straightforward. So now again, we just write down the formula NT equal to N0 times e to the KT. And we just throw in whatever we have, right? It's NT using 2N0. K, we're looking for that, T is 35. Okay. Then the first step, dividing N0 from both sides equation. Initial population, cancel that, cancel N0. So E 35K goes together equal to 2. Okay. So now from there, we just taking the LM from both sides equation, and taking LN here, taking LN on the right. Okay. Then we simplify, so we get 35K equal to ln of 2. Okay. Then we just divide both sides equation by 35, and we should get the result. Okay, so divide 35 from both sides equation. So K equal to ln of approximately equal to ln of 2 over 35. So now one more time, let's put into the Excel. So this is ln of 2 by 35. Okay, let's see what that is. You can run it to, in this case, we can run it to 4 decimal places. So in this case, if you want to turn it to percentage, right, you can also do that. Go to format cells and then percentage with the 2 decimal in percent. So this is 1.98% we're looking at. So we'll go back. So this is approximately the growth rate. Annual growth rate is approximately 1.98%. If you want to double the population in 35 years, that's what happened. Okay. And let's look at just last 2 questions from the exercise. Now let's take a look at 10 and 12, and we move on to Excel project. So all the even ones, we know all the even ones, 10, 12, and that's all. Okay, so let's go over the solution for those two questions, 10 and 12. There you go. So question 10 first. So we have this growth rate of 0.6% per year. How long before indicating we're looking for time t? And then again, doubling the population, right? Doubling the US population. So right here, K is given, K is 0.6%, which is 0.006. So turn into decimal first. And then doubling meaning NT equal to twice of N0. 2 times N0. Then here we're just solving for time t. So first of all, we get NT equal to N0 times e to the KT. And we're just throwing all the given information. So NT becomes twice of N0. And N0 times e to the K is 0.006%. 0.006 times time t. Okay. Then dividing N0 from both sides of the equation. So that. And reverse order, meaning e raised to 0.006 t equal to 2. And from there, we just taking ln from both sides equation first, e 0.006 t equal to ln of 2. And simplify ln and e offset each other, so we get 0.006 t equal to ln of 2. Now, one more time, we dividing the coefficient from both sides of the equation. So dividing 0.006 from both sides of the equation, then we get 20 by itself. And one more time, let me use Excel. So this is ln of 2 dividing by 0.006. See what that is, and now you see that it's 115.5 years. So now when the growth rate is low, then it takes much longer time, double. Remember the previous one, it only takes 35 years because the growth rate is much higher. So this is 115.5 years. All right, so that's how long it takes to double the U.S. population with this growth rate, annual growth rate. Any question on this? Okay, last question from exercise 2.3, question 12.
Professor?
Yeah, sure. Yeah.
So I just had a quick question. When you do the process, when you're dividing basically the letters on either side to get the numbers by themselves, is there a way, I just want to understand the purpose of that part of the process, if it's going to be getting rid of anyway?
Oh, you mean
so like, okay, where you see you have 2 n0 equals n0 times e to the exponent. Since it's I mean, we want to get the numbers by itself. Isn't there a way we could just skip that step and make it even simpler of a process, or should we not do that?
Oh, another way. Yeah, you could do that. I'm going to quickly show you. You can assuming n0 equal to 1. I mean, right? You can make assumption n0 equal to 1. Then nt must be 2, right? So instead of writing nt n0, you can just try 2 equal to 1 times e to the kt. That's totally fine. If you want to go that route, if you feel like that's a lot easier for you, you can assuming there's only one person, 1 billion or 1 million person for the initial population. Then after a certain time, it becomes 2 million or 2 billion, right? Something like that. Then you can just easily you can just easily divide 1 from both sides. You can even just skip that one, and then jump right to e2 equal to e to the 0.006. In that case, you don't have to deal with the actual variable here, right? No more variable, just the number itself. And
okay.
Yeah, if that's helping, you can do that. Yeah.
Okay, thank you.
Okay, no problem. Yeah, definitely, you can always make assumption, right? n0 equal to 1, then nt becomes 2 unit, because it's doubling. Okay, if it's tripling, then nt becomes 3 units of n0. Yes. Okay, and then here let's look at the last question, question 12. But that's very good concern. Okay, and 12. What's the doubling time of a population that grows by 80% in 45 years? Okay, so again, here maybe let me just make assumption here. So grows by 80%. Okay, so we can assuming the initial population equal to 1 unit, right? We can do that. Now nt, since it's growing by 80%. Should be 1 unit plus 80% of 1 unit. Okay, so in that case, you don't have to deal with the variable, but instead we have a very small number to deal with. That probably would be easier. So 1 plus 80% is 0.8 times 1. So this turned out to be 1 plus 0.8 is 1.8. That means after 45 years, the population becomes 1.8 times as much as the initial population. So we're assuming initial population as 1 unit, and now it's 1.8 units. All right. So so basically there are 2 questions here. First one is, based on this given condition, we can find out the growth rate K. because time t is also given. The first thing we need to figure out is k, because k is not given here. And once you find out the k, then we'll be able to go back and find out the doubling time, right? So there's two-step process. First one, find the annual growth rate k using all this given information now. So nt equal n0 times e to kt. We still stay with the same formula, exactly. So nt is 1.8 unit, n0 is 1 unit, and times e, and the k times t is 45, so k times 45. And here, the only thing we don't know is k, so let's solve for it. Solve for the k. Now, reverse order, we get E45K equal to 1.8. All right. Now we're taking the Ln from both sides equation, Ln of E45K on the right. (45K) on the right is Ln of 1.8. Now, simplify a little bit. Ln and E offset each other. We get 45K equal to Ln of 1.8. Now, from there, we're dividing 45 from both sides of the equation. And then we cancel that. So K equal to approximately. Let's see what that is. Let's go to Excel, find out the result. So this is Ln of 1.8 by 45, yeah. Okay. And this turned out to be this, all right? So here, in order to keep it accurate, so we're gonna keep all these digits, meaning we keep the entire decimal just for the doubling time to be more accurate. So more decimal actually means better result. So we're gonna keep it as 0.013062. 0.013, yes, so this is approximately 0.0130 162, is it? 062, yeah, 0.013062. Yeah, so we keep more decimal just to make sure, you know, we have the more accurate doubling time when we get to doubling time. So now let's work on doubling time, right? Once we know the rate, doubling time. So now K is given. It's 0.013062. And assuming initial population 1 unit, doubling time meaning NT should be 2 units, right? Double that. And from there, we'll be able to solve for time t. So NT equal to N0 times e to the KT. And then we throw in all the numbers. So 2 equal to 1 times E. K is 0.013062 times T. So from there, we just simplify a little bit. So reverse order E raised to 0.013062 T. That's equal to 2. Now we're taking the Ln from both sides of the equation. Simplify, then we should be able to get the doubling time. Equal to Ln of 2. Again, simplify, Ln and E cancel each other, so we get 0.013062 T equal Ln of 2. Now from there, we're dividing both sides of the equation by 0.013062, 0.013062. And cancel that, time t is by itself. So time t equal to Ln of 2 by 0.013062. One more time, we put into the Excel. So it's equal to Ln of 2 divided by 0.013062. Okay, and that should give us a doubling time. Okay, and that turned out to be 53.1 year. Right, we can run into one decimal places. 53.1 year. It take about a little bit more than half a century to double the population. So time t here is approximately 3.1 years. And I hope this helps a little bit. Yeah, you can always make assumption, initial population is 1 unit. Since it's not given here, right? Any assumption you're making, it's okay. Like 1 unit, or 1 million or 1 billion, right? Something like that. That's totally okay. All right. But yeah, in this particular problem, we have 2 steps because K is missing here. So the annual growth rate is not given. So we need to get that first before we can work on the doubling time. Once we have the K, then we can work on the doubling time issue, and I get the doubling time from there. Okay. Do you have any question from section 2.3? Again, we only work with one formula, right? Although it has, we use a lot of algebraic manipulations here, like logarithm and exponents. But yeah, we only deal with one formula. Okay. All right. Before we go to your project, I just want to show you something really quickly. I posted a note, Excel note from the last class. So if you, let's say you want to look at the Excel operations, I show you, I posted right here. In class Excel demo from Wednesday, and all the Excel operations I perform, is presented there, so you can use it as a reference. And also, and let's open this file for your second part of project number 3, right? So, second part of project number 3 is about a salary, how to calculate salary. Let's open this Excel file. And let me share the screen with you. All right, here we go. So we have some employees. Let's say you have a startup company, right? And you have some employees, and you need to pay them, right? Also, you need to meet those government obligations, like you have to pay the retirement account, and then also the payroll taxes, all those due to the government. And this is just a very good exercise, help you, get some experience in terms of doing the spreadsheet and figure out the total salary, payroll tax, retirement contribution, and also arrive at an employee's net monthly salary. So even though, so this is very good, system to use also for the accounting purposes, you can keep track of all the spendings and all those in terms of the employee salaries. All right, so now the question is asking us, each employee is paid an hourly wage plus $2.25 for each unit he or she produces. So this is like bonus, right? Like something like commission. So if unit produced, you pay an employee $2.25 based on their performance, right? In addition, the employees pay time and a half for overtime. So overtime pay is 1.5 times as the regular salary. And from the gross salary, 8.25% is taken for various payroll taxes. So you pay taxes. You also need to contribute towards their retirement account. So 7% is taken for a retirement account. And you create a spreadsheet that calculates gross salary, meaning total salary, right? Combine the hourly salary, also the commission on the unit produced, and also the overtime pay. So the total salary has 3 elements. Okay, let me just list it here. Is the regular pay, regular salary, commission from the unit produced, overtime pay. Okay, and then we need to calculate the payroll tax. We know that that's 8.25% of the gross salary, and then retirement contribution is 7% of the gross salary. But before that, we need to calculate gross salary. So we're gonna create this item called gross salary. Okay. And also, we need 2 more titles here. One of them is payroll tax. another one is retirement contribution. Retirement, right? Just make it simple so we don't use too much space here. And after that is net pay, right? Net monthly salary. Once we take all those taxes and then also the net monthly salary. Okay, so let me just highlight those. I'm going to put into a table form so you can see that. So now let's work on a gross salary. So remember, gross salary, 3 parts. Regular pay, right? So hourly salary times hours worked during the normal hours. That will be the regular pay. So it's 15.45 for Amy. The hourly rate is 14.55. So we're going to use the cell C14 multiplied by D14, right? As a regular pay. So this part is regular pay. Adding the commission. So commission is $2.25 multiplied by the unit produced, right? E14. Okay. And then we add in the last part is the overtime pay. So overtime pay is 1.5 times as much as the regular pay. So 1.5 times hourly salary, C14, and then multiplied by the overtime hours, which is F14. Okay. And that should give us all 3 elements in terms of the gross salary. Okay. And then he enter, I should give you the result, right? Okay. So the total gross salary for Amy is $3,523.43, right? So typically we just run it to decimal places because we're dealing with the money. So yeah. And also if you want to put in a dollar sign here, we can do that. We can just format the cells and go to currency, right? A symbol. No, actually, I'll go to accounting and just pretty simple dollar sign. Yeah. And then, yeah, 2 decimal. That's enough. Okay, don't get that. So this is gross salary for Amy. Then payroll tax.
Can I ask a question about gross salary?
Definitely. Go ahead.
Okay, so it's the hour salary times hours worked plus
Yeah.
commission times unit produced, and then what else?
And then plus overtime pay, right? Overtime pay, they have some overtime hours. Overtime pay is 1.5 times as much, right?
Where do you get the 1.5?
It's from the information above.
Oh,
In addition, the employees pay a time and a half for overtime hours.
okay.
Meaning, based on the hourly salary, as an employer, you need to pay 1.5 times as much. So 1.5 times, in this case, Amy's hourly salary is $15.45 multiplied by that, and times overtime hours.
Okay.
Makes
Thank
sense?
you.
Okay, very good. So 3 elements, right? Remember when you calculate that, make sure you do not skip any one of this. And also the overtime pay is 1.5 times as much as regular hourly rate, okay, hourly salary. Okay, so we have that. Now, and let's calculate the payroll tax. Okay. Payroll tax is 8.25%. You can just put in 8.25% of the gross salary, right? Okay, so we have that. Here we go. And then also retirement contribution is also 7% of a gross salary. So 7% times gross salary of G14. Right? That, look at that. Now the net monthly pay, okay, should be the gross salary minus payroll tax is deduction, right? Payroll tax deducted from the gross salary, subtract the retirement contribution. That's also deduction. And then that will arrive at a net monthly salary. Okay. And I want you guys to try for team, right? Try team, see if you can come up with the right result. I give you a couple minutes. If you know how to do this, then you have no problem completing the Excel project number 3, right? I give you 2 minutes. Work on
I have
that.
a question.
Definitely. Yep.
So for Excel project 3, for the salary thing, I used my calculator. I didn't really use Excel to calculate it. Would I get points off because I didn't use Excel?
Yes, you get points off. The thing is, all the Excel projects supposed to be completed in Excel, right? So you cannot use any other like tools like calculator or do it by hand. That defeat the purpose. So that's why some of you guys didn't get 100%. That means getting some points off. Maybe you didn't follow the right formulas, or maybe you didn't use a formula at all, right? For the previous 2 projects. So yeah, the answer for that is yes, you have to compute everything in Excel using the cell, using what we learned so far. And if you need help, let me know. During the breakout session, I can help you a little bit to get you started, or maybe I can also check your project, right? Let's say you have doubts or you have confusion about a certain part of project, and you want me to check it before you submit in the project. You can also do that during the breakout session. And I can quickly check the project, and then you can submit it after that. Okay.
Professor?
Mm-hmm.
Hi, I have a question. Does it matter if I set up the table slightly different? Like I just put after overtime, I had put the net monthly, and then I had put gross salary, payroll tax, and retirement contribution. So does that matter or no?
Doesn't matter as long as you follow the right sequence, right, and get the right result.
Okay.
That's totally fine. I don't mind. Yeah, the order, it doesn't matter too much. Yeah.
Okay, thank you.
Okay, that's great, Victoria. Okay.
Professor, I got one question.
Sure. Yes.
For the gross salary, I didn't use that same exact formula, but I think it's the same answer. Because
Okay.
instead of
how do you do that if you do not use the same formula?
I think I took the hourly to when I was adding the hourly salary to the overtime hours, I added the hourly salary like 2 times, and then I divided it by 2, like a time and a half basically.
Okay, so you branding into that. As soon as you have the same result, meaning you have the right calculation, I'm fine with that, right? There are many different ways of doing this. I just want to show you one way so you have some idea how to get started. But definitely, if your method works, stick with it. I don't have a problem with that.
Okay.
Yeah, as long as the result is the same, right? You arrive at the same answer at $2,986.10, right? Based on calculation, that's fine. Yeah. Okay. Yeah. Okay. So let me just quickly go over the solution here, so you guys can get started on the second part of the project. So one more time, and here actually, once you do one of them, you can just drag it, right? Then yeah, it will do it for you. So you don't have to do all this. Yeah, you can just drag it. Yeah, no problem. Okay. But the formula will be this. Okay, here we go. You will follow the same exact same format, and then get the rest of the answers properly. But make sure the first result is right. Then after that, you can just drag it. Okay. Yeah, that's pretty much. I can post this for you if you need it, and let me just save it and then post it on a Blackboard. Then you can use it as a reference again to complete your project number 3. And then you can use any method, right? And let's say you set up the table differently, totally fine. I don't mind. Yeah, as long as you have the right result. Right? Yep. And I think you could complete a project number 3 with no problem once you understand what we're talking about so far. Even you with your own method, totally fine. Okay. Okay, then yeah. Any question before I put you into breakout session? right, so let me put you in there, breakout session. Okay. And hey, Chloe.
Yes.
I have a
So I
question.
can submit my project. I'm the one that did it with like a calculator.
All right. So do you want to redo it? And that's fine. You can just redo it and then resubmit it. If you submit it already,
Yeah,
you,
I kind of
yeah,
submitted already.
no problem. Yeah, you can just redo it and resubmit it. Only the higher grade will be counted in the
Okay.
Excel. Yeah, don't worry about that. Okay. Yep. Hey, Tabinda.
Hi, Professor Lee.
Yes.
Okay, I'm gonna share my screen.
Definitely, sure.
Oh, it says host
Okay.
disabled.
Yes. You just I just enabled that. You can try that one more time.
Okay, got it. So I did this like 2 days ago and I didn't know that you were gonna go over it.
Okay.
So the way I did it all on Excel,
Mhm.
but I wanted to remove the things that the totals that they didn't ask for. So
Sure.
basically I copied it and I clicked value where it says like here, and I
Mhm.
did value.
Okay. Okay.
But now the problem is, so I got rid of that, but it kept everything else. But the problem is you can't see that like what I did, but I did it exactly like you.
Okay. So
I wonder if
basically,
maybe I can go back, do you think?
I think so. You can go back. I
But
think.
then
Mhm.
I think it would eliminate like this.
It's,
Like, is there a way to go back specifically to something like here?
I don't think so because you already saved it, right? Once you
Yeah.
save it, desktop or laptop, then you won't be able to go back too much. Maybe just one step backward, but it doesn't. That doesn't help too much.
Yeah,
But
this doesn't allow me to go back anymore.
yeah, I see. But since you already have all this input, it doesn't take too long to calculate one of these, right? You
Okay,
can
okay, yes.
put into the formula one more time, then you can just drag it really quickly. You get a result. Yeah, you get all these results very quickly. Yeah. So
All right,
maybe,
okay, I'll do that.
yeah, do that, please. Yeah.
Okay, thank you.
Okay, no problem. Hey, Casey.
Hi, Professor. I wanted to know, can I ask you questions on the homework? There's a few that I was confused about.
Definitely. Yeah. Do you want to
Okay.
share your screen, or you can tell me the question number so I can look it up?
Okay. Let's see. Oh, I don't have the homework opened or the textbook. I wrote it by hand. Is it all right if I do you want me to put it into Word or Excel later, or can I take pictures and make that a PDF to submit?
That's fine. Yes.
Okay.
I don't mind. Yeah. That's
Okay.
fine.
So let's see. Let me scroll down the textbook.
Or maybe even I can open it. Do you know the section number?
Yeah. So okay, I've got a question for section 1.5.
You can see the screen, right?
Yeah.
Okay.
Yeah.
All right. Very good. So let's go to 1.5. Let's look at it. This is 1.8. Maybe page 15. 1.5. Okay, which question is that?
So it was number 3. It was the last part of number 3 that I think I was stuck on.
All right, I see. So the value of the piece of equipment depreciates linearly and costs $135,000 new. Each year depreciates 10%. So 10% of 135,000 should be $13,500, right? That means each year you depreciate $13,500. That will be your slope, right? And then it's negative.
Oh, okay.
Yeah, so that's, so here slope should be, let me share the screen. Slope should be 10%, which is negative 10% of 135,000. Slope turned out to be negative 13,500. Okay, and then the y-intercept b. Let's see what that is. It's let's see. Yeah, because so that means initial value is 135,000. That means y-intercept b is 135,000. If you know both, then we're using this mx plus b, applying both numbers, we get a negative 13,500x plus 135,000.
Oh, okay.
Okay, so that should be the equation for that, for this scenario.
Gotcha. Okay.
And yeah, that should be the equation. Yeah, that would be the equation.
Yeah, these I feel like kind of silly that these were questions that I probably should have gotten, but for some reason they stumped me.
No problem. Yeah.
And then number 7 on the same section.
Number 7, sure. Okay, the slope. Okay, and this one is a little bit interesting. So slope of roof expressed as pitch, a 4 pitch roof increase vertically 4 inches for every foot. So now we have 2 units. One of them is inches, the other one is foot. That means we need to make it consistent, right? Be in the same unit. And then we know that foot is a higher unit. So typically we're converting a higher unit to a lower unit. 1 foot equal to 12 inches. So that's something we need to do.
Okay.
Here. And in that case, we'll be able to keep it consistent across. You can see the screen, right?
Yep.
Okay, very good. So here, 1 foot equal 12 inches. So we get that. So if the lowest part of 4 pitch roof is 14 feet above the ground. So now again, this is 14 feet. We do 14 times 12. Okay, and that should be, let's see, the calculator. Let's see how many inches that is. 14 times 12, that's 168 inches. And that is what we call the y-intercept, right? It's above the ground. It's above the ground. And then for every 4 pitch roof increase vertically 4 inches, for every foot horizontally increases. So now you want to relate the height of the roof. So that's vertical height, which is horizontal. Okay. So here you go. We're assuming x is a horizontal distance. Now here we need to find out the slope, right? Slope is not known yet. Remember, slope is vertical change over horizontal change, right? Vertical change here is 4 inches. And horizontal change is 12 inches. So slope is 1/3.
Got it.
So now, and then y-intercept is b is 168 inches.
Yeah. Okay.
And we have the equation, right? So that should be y equals mx plus b, so it's 1/3 of x adding 168 inches. And that should be the equation you're looking for.
Gotcha.
Make sense?
Yes. Yeah.
Very good. Yes.
And I think that was it.
That's it. Okay.
Yep. And I think I was okay. I think the Excel I'm all right with, but the last part I think I got, but I was just maybe I can share my screen and then
Let me stop sharing.
yeah, because the first two graphs I don't have I'm waiting for my new scientific calculator, so I don't know if I did the equations right and graph them right, but I'll show you. And
No problem. You can share your screen.
yep.
Right. I see your screen. Yeah.
You can see it. Okay.
Yeah, I can see it. Okay, and go ahead. So you just want me to check it, right?
Yeah, yeah.
Okay, just click on a cell C9. Let me see the formula. Yes, that will be 3 raised to 4 minus x. You will put 4 minus x in the parentheses.
Okay, so
that means 4 minus B9 should be in the parentheses.
Parentheses?
Yes, otherwise the result will be off. Yes, now you drag it.
Ah,
yeah.
Okay, that looks better.
Yeah, okay, very good.
Okay, so then maybe.
Yeah, so let me see the other one. Is a 3/4 raised to t minus half. Same thing, right? T minus half must be in parentheses. Very good. Drag it.
Okay.
And get rid of that.
The linear one.
It should be curve. It should be just let's go there. Yeah, get rid of the linear model from there.
And do
exponential.
Exponential.
Yes.
How do I get rid of the? I don't know how to get rid of it.
No problem. You can just delete the entire graph and then
and just redo it. Okay.
Yeah, redo it, yeah, that'll be easier. So double check that maybe.
Oh wait.
Now it's good. So
yeah. Okay. And then I can just
exponential model.
Re-add it.
Okay.
My Excel's being really slow, but at least I know how to do it.
Yeah, definitely.
And then I guess while I have you here, I might as well just scroll down to this part. Hang on, let me make this bigger.
You did it earlier, right? So
yeah. So I also did it like I didn't how you just showed it in class. You times everything together. I actually broke down it over time, and then so it was easier for me to like put it into gross salary to make sure I wasn't doing it wrong.
Definitely. This is a lot better. Yeah, I think you break down. You have also have a better idea.
Yeah.
Yeah, that's definitely
easier to follow.
That's great. Yep.
All good. Okay. Cool.
All good. Yeah.
All right. Thank you so much.
No problem. All right.
Bye.
Bye-bye. Hello.
Hello.
Hey, Songha.
Oh, hi, Professor. So I will share my screen.
Yes, you can share your screen. Sure. Go ahead.
Okay, can you see my screen?
Yes, I can see that. Yep.
Yeah. So I did the first questions of the project number 3. So for the number 1A question is fx equals like
That's good. Yes, you have the right result. Just click on B8. Let me see the formula.
B8.
Yes.
This.
Yeah, any one of that. Yeah, that's fine. Yeah, so you have the right formula. It's all good.
Okay. And my question is number B. So is it right?
Yeah, just click on yeah, that's fine. Just click on cell B24. Let me see the formula. Yeah, your formula is good. So that means the result is good. Yes.
I was confused about like in this equation I put the parentheses.
Yeah, that's fine. Yeah, that's fine. It's a fraction. That's fine. Yes.
Okay, then this is the right equation, right?
Yeah, it is. It is.
Yes, thank you. So also I downloaded the salary example Excel that you uploaded a few minutes ago, but in there
Oh yeah, I changed the file. Yeah. So do you need
yeah,
a original file?
so sorry.
I upload a solution there, so you can use a solution file. I just want to show you the solution so you can use it as a reference. Maybe I did this.
Sorry. Yes. Yeah. Sorry.
It's okay.
You still my Excel file, right? You still see my
No,
Excel.
I don't see your screen. Maybe
Oh,
sometime. Maybe the internet's slow. Yeah.
oh, okay. I will try again.
Try again. Yes.
Same screen.
Yes, saying it says has started screen sharing. It says,
Oh,
but I cannot see your screen yet.
oh.
For some reason.
Okay.
Oh, the worst scenario, you can email to me. If you want me to check yours for you,
Oh,
you can just email me. I will look into that and I'll get back to you.
actually, I like.
Yeah,
Oh,
I can
no.
see that now. Yes, it's good.
Yeah, okay. So this is the Excel file that you uploaded.
Yeah,
That I cannot see any like the equation like.
Oh, okay. You can open a new file. I just upload it right now. So you can open a new file. It has all the formulas there.
Oh, so you uploaded your
Yeah.
file. Oh, okay.
Go
Thank
there
you.
and open a new file. Okay.
Okay. Thank you so much.
No problem. Okay.
Okay. Then one more question. In the number 3 project, number 2 question. So I need to calculate the gross salary, payroll tax, retirement contribution, the net monthly salary for each 8 employees, and it is said that add up the total hours worked and total gross period. That means should I have to add all hours of the employee?
Yeah, you could do that. You could just create a total column underneath and add just add a couple of whatever they ask you to add, right? Let me see. Yeah, so whatever the question asks you to add, you just add those. Create a total in on bottom. Yeah.
Okay.
Makes sense.
Yes, okay, I understand.
Okay.
Thank you.
No problem. All right. Hey, Tabina.
Hi, sorry.
Sorry.
I wanted to just show you before I turn it in, just to make sure it's the way you want it.
Definitely. Go ahead.
There we go. Okay, so I did it like this, and it matched my numbers, and this doesn't ask for the total, so.
Or maybe just click on cell F32. I just need to see the formula. Make sure it's all
At
good.
32.
Yes. Yep. Okay, 1.5 that. Okay, very good. Yes, you have the right formula. And so that means the result should be good. Yes.
Okay,
Mhm.
perfect. So I'm going to turn it in now.
Yeah, definitely.
Thank you.
Great, no problem. All right. Isabella, I was with your classmates. I just finished with them, so I joined your breakout room.
Okay, no problem. I had just emailed you like a few days ago about like the first lab.
Sure.
Like when I tried doing it, I got a lower score. I was just confused on that.
Definitely. Let me go to your account.
Okay.
Can you see the screen?
Yeah, I could see it.
Okay, very good. So let me go to a submission, and then I will win over your anything to improve. Then I guess you can improve on it, and then I will still let you submit it after that. No problem.
Okay.
Excel project number 1, right?
Yeah.
Okay, let's view the grade details and view attempts. Okay. All right, so let's see. Attempt 170. Okay, so let's see. So this is attempt number 1. You get a high score on this one, 70. Let's see what goes wrong there. Cannot open tool. Okay. All right, here we go. And let me share the screen with you. Okay, here we go. Can you see it? Can you see your Excel project?
Yeah, I could see it.
Okay, so first of all, you see, here you just put the answer, right? You're supposed to calculate it step by step.
Okay.
Right? Yeah, it's only, yeah, that like this one only answers. You should do like the second one you did, right? You put in the equations like that, and let's calculate the results.
Okay.
Here, yeah, this is okay. This one is okay, and this one the result is off for some reason. So let's take a look at it. So 2x over that, and this is not needed. This one we can just make it a lot simpler. 2x over 5, that's good. And then 8 times 4x minus 7. Okay, that's good on top. And then denominator should put in parentheses. So missing a parenthesis here. Okay, and that should do it. Yeah, so that's why the result is slightly off. So you need to fix that.
Okay.
Does that make sense to you? Okay.
Yeah, that makes sense.
Okay, very good. So denominator should always, if denominator has more than one number, meaning denominator has operations, it must be input into the parentheses.
Okay.
All right. And this one.
Was the second one right? The 410?
The second one, no, it's not. It should, yeah, you should still do it step by step, right? Using this instead of just putting the answer, right?
Yeah.
Okay. Okay, so fix that, and then I can let you resubmit it for better.
Okay.
And this one, yeah, same thing, right? You have to put in the entire thing before you can get it. But I can show you how to do this. Okay, you do EXP, right? Remember, for exponent with base E, and then you do 2 times -3. Okay, and -1, and close parentheses. That's a proper input.
Oh, okay.
Okay.
All right, thank you.
All right, no problem. So that's the result. So this is also off. And also fix the other one, right? The other one, you need to fix it. Okay, H of 4. And then here, again, it's only answers, no calculation, right? You need to put in the calculations 3 times x, which is -1, and raised to -2nd power. Okay, that's a proper input. Right? Once you input is 3, right? Okay. But the formula is needed, right? This is needed. Okay.
Okay.
All right. So do that. And the second one you did put in the formula, you're good. The third one still need a formula.
Okay.
And this one, yeah, so still the formula, right? We need a formula. So 5 times equal to 5 times 1.23 raised to 3x. So put 3 and x in parentheses. 3 times is C what? First one is C -2, so 3 times -2. Okay, then that's the proper input. And once you do that, here enter, that's the result.
Okay.
All right, and same thing here, right? And put in a formula, get a result.
Okay.
And here, same thing. There's no formula at all. Let me see if you put in any formula. No formula here. I know this calculate. This is one thing you can do is you can just copy this, right? Since you already input it, you can go up here, copy the entire expression and paste it here, and then change the x to. It's not letting me copying this. Or maybe putting different cells. Yeah, I think so. Putting different cells. Okay, so yeah, this input slightly off. Okay, so here's the formula. I need to open the sheet. Go to let me open the project number 1. Yeah, the last one is quite lengthy. It has a lot of operations involved, so it takes some time to input it. But yeah, let me just copy this. So 3 times n times 3x plus that. Okay, plus. Let's go back. Okay, yeah, the whole thing. Yeah. Can you see the screen right now?
It's not showing like what you're
Not
doing.
showing. Okay, okay, not showing yet. So let me just go back. For some reason. Okay. Give me 1 second.
Okay.
For some reason, there's a little technical issue right now. So let me fix it. Okay, here you go. I find it. So let me share with you. Okay, here you go. Can you see the screen now?
Yeah, I can see it.
Okay, very good. So you do this 3 times, right? The entire thing is 3x, so 3 times x is 3, and adding another one 4x, 4 times 3, and adding 4 over by 3 times x is 3. Okay, that take care of the first part, right? And then after that, you add in the second part, it's 4 times So again, we're going to put the numerator in the parentheses. So 4 times 5 minus 2x, 2 times 3, close it, and adding 5 in the back. Okay, and close it. All right, that's numerator. And then dividing by 2x, 2 times 3. And after that, adding 2 in the back. Okay, now
Okay.
that's great. Okay, now he enter. Okay, find a typo in your, okay, this. Go back, check, and 3 times, yeah, missing a parentheses here. Okay, let's do it. Now you get 34.5. Okay, and that's how you import it.
Okay, thank you.
All right. And I can email you this so you can, let me just save it. So and then after that, I email to you for you as a reference.
Okay, thank you. Are the graphs right? Like that
Let me double check the graph. Yes, first of all, let me save your project. Correct. Yeah, no, graph is not right. That's why the points off on there too. So the first graph, let me see. And again, do not just put in the numbers, right? As I mentioned, we need to define the slope here. So no worry, I'm going to show you how to redo this. So you're going to define the slope here. Slope is 7, I think it's negative, right? Negative 7.5. If you look at the lights, you don't need the column here. I'm going to define slope here. So slope is negative 7.5.
Okay.
Y-intercept is 60. Okay. So we need to fix this as well. It's minus 7.5x. And now you're going to do this. You multiply this number by this, and then we use absolute value, absolute reference, put a dollar sign in front of B, put a dollar sign in front of 38, right? And then after that, add in the y-intercept. Same thing, we use the absolute reference, log the cell for the y-intercept. When we get that, then you drag it, right, to get the rest of them. Okay, and this is a correct graph. Okay, yes. And the graph should be minus 7.5x. I think that should be the case. Let me double check. Yeah, it is minus 7.5x.
Okay.
And that fixed the first one. And second one, similarly, right? You define the slope and y-intercept, and then this is not. So again, slope, define that is 12.5. Y-intercept here is minus 40, negative 40. So same thing here. We delete everything here and put in the formula. So we have this number multiplied by slope, and we put in a dollar sign in front of this, dollar sign in front of row and column, add in the y-intercept. Same thing using reference, and then he enter. Then it should get one of them, and just drag it to get the rest of them. And this one, yeah. You see, you have your graph has a little like horizontal line attached to it for some reason, and that's not right. Okay, so that's why, yeah. And this is a proper way of doing it. And let me just email you this file right now, so you can go by. No problem. And I can reopen it, and you can resubmit it yourself. Okay.
Okay, I just have one last question. For the lab that we have to submit today, for number one, we have to graph both of those functions like on the same graph?
No, not on the same graph, on a different graph.
Okay.
On two different separate graph. Yeah.
Okay, thank you.
All right. Let me email over the updated version of the project number 1. Okay. Yeah, the internet is kind of slow now. That is you, right, Isabella?
Yeah, that's me.
Okay, okay, very good. Updated project. Attach the file right now. You should get it. Yeah.
Thank you so
And then
much.
use that as a reference. All right, no problem. Fix it, and then I will open the Dropbox so you can resubmit it.
Okay, thank you.
You finish. All right, great. No problem. Any other question?
No, I think that's it.
Okay, perfect.
Thank you for your help.
All right, no problem. Okay, guys, the class is over, and I guess I'll talk to you guys next Wednesday, right? Have a nice weekend.
Thanks, Professor.
Yeah, I was.
Thank you.
Bye, guys. Thanks.
Have a good one.
Bye-bye.